Hello and welcome to the third video in the mini video series on Linux Essentials. In this video series, I'm providing you with some inside knowledge on the top things I think you should really know when using the Linux CLI. I'm cutting through the noise and I'm just picking the top things you should know rather than showing everything by rote. So I'm hoping this will be streamlined and very useful. In this video then, we'll be looking at 4 topics in one go. Firstly, we'll be looking at how to use the htop utility to monitor processes and memory on your system. This is a fantastic utility and a must-know feature for checking on your system's health and seeing if there are any resources reaching limits on your computer. It's also a very convenient tool for filtering through running processes and, if necessary, terminating them should you wish. Next, we'll look at how to clear or flush your virtual or swap memory. This is very important if you recently had a memory-heavy process use a lot of virtual memory and you want to ensure your system performs well afterwards. Then we'll talk very quickly about how to restart your system, which is nice and easy, followed by how to update your system and what that actually means for your distribution. You might be surprised to discover that using the update command actually doesn't update any of your packages whatsoever. Okay, great. Let's head over to my desktop then and get started with looking at htop. But before I do, I just want to raise to your attention my Patreon account. If you're interested in accessing videos that aren't available on YouTube or would like one-to-one support for issues you have with my course with myself, or if you would just like to support my work, please do visit my Patreon account. I wouldn't be continuing to make videos if it wasn't for my existing patrons. So thank you very much to those, and I'd very much appreciate any further support anybody could offer. Okay, let's head over to my desktop then. Okay, so here I am on my desktop, ready to go with my bash terminal presented in my user Pi's home directory, as discussed in a previous video. Firstly then, I'm going to check that I've got the htop utility installed. Of course, I know that I do myself because I use it all of the time, but htop doesn't necessarily come as standard on all distributions. So it's a good idea to make sure you have it. So first, let's install it. So type as I type, sudo apt-get install, followed by the name of the utility, in this case htop. Now this command to install a utility is very common indeed. We use sudo to elevate our permissions so that we can install the utility globally on the whole system. We use apt-get, which is the name of the utility, and that draws down the application or the package from the distribution's repository. And of course we use install to install it onto the system. As you can see, in my case, I already have it installed. With that done then, we can access htop simply by typing htop into the command line as follows, and then press enter. Firstly then, let's have a quick look around htop and get a feeling for what we're looking at. It's quite simple once you get to know it. Firstly, I'm going to mention the bottom. You've got a series of shortcut keys here, F keys basically, F1 to F10. We're going to be using a few of these, the ones that I consider to be the most important, in a few minutes. But I just wanted you to know before we get started that you don't have to memorize which one is which, as they are referred to down here. It's just useful that you know that these functions I'm going to explain do exist. That's the main purpose of this video. Okay, starting at the top then, we have the processor usage boxes. There are 4 of them for my Raspberry Pi because I have a 4-core processor on my Raspberry Pi 4. Currently they're pretty much idle, so these are close to 0%. On the right, next to the CPU boxes, we've got the number of tasks running on the machine, and we've got the uptime, which is the time that the machine has been up since its last restart, in this case 5 hours and 2 minutes. If the machine is being heavily used, obviously the CPU boxes will be closer to 100% as opposed to 0, and these bars will be across the screen as opposed to empty. Now beneath the CPU bars are the two memory bars, mem and swp. This is memory in terms of RAM and swap in terms of virtual memory. Okay, so let me just... Virtual memory, sorry, I was losing my thread there. Virtual memory, or swap, is nothing more than a file on your hard disk, which acts as space for the RAM to overflow into. That's all it is. You may not be surprised to hear then that when we're using swap, which is on a hard drive, your system will necessarily be running slower. And that's because your hard drive, even an SSD, will be slower, and quite a lot slower actually, than your RAM. So keeping an eye on this box is very useful. You really don't want to be using it, but it's a very useful overflow to prevent your processes from crashing if they just happen to use a little bit too much memory. Okay, continuing on with our tour then. Beneath the memory bars is this giant list. It's the process list, which shows us what processes are currently running on the machine. In my case, I've got various things running. I've got Docker containers running. I've got fail to ban server running, for example, among other things. The most important columns in the process list for you to understand and keep an eye on are as follows. The user column, which tells us who started the process and who owns it. The CPU and memory columns, which tell us how much CPU and memory the processes are using. The time. Now the time is the amount of time the process has been using a CPU for. So this is often static for some processes which are idle and will be going up regularly if you're running something at 100%. The last thing of importance is the command column. The command column tells us the command that was used when the process was started. So that's basically it for what htop is and how it all is laid out. Let's now look at what we can do with htop aside from just eyeballing the default layout. Well, firstly, the process list is by default ordered by the longest running to the shortest running process from top to bottom. And you can see that by the fact that the top process has got 12 minutes of runtime on it altogether, or actually that could be 12 seconds, I think. And then it goes down and down to the zeros into the milliseconds. So this is great, but what if this isn't what we're after and this isn't particularly informative for us? And often it isn't. Let's say we want to order instead based on memory. And this is actually a very common thing to do because memory is a commodity often in short supply, and looking at what processes are using the most memory on your system is a very common thing to want to understand. So to sort our list based on a particular column, in our case memory, we're going to use F6, and we can see at the bottom here F6 says sort by. So if you press F6, it all bunches up a little bit, and on the left you can pick what column you want to order things by. In this case I'm going to pick memory. With that done then you can see the processes ordered by the amount of memory they're using up. Okay, now this is very useful indeed. But what if we want to invert this and see which processes, for example, are using the least amount of memory? Well, there's a shortcut key for that. You just press the Shift key and press I for invert. And you can see that I can invert it from smallest to largest and vice versa. Okay, that's a really useful thing to know. So we now know how to order our processes by column and how to change the direction in which they are ordered. Now let's look at how we can search for a given process. Why would we do this? Well, imagine you want to check something is running, but it's lost amongst the noise of all of your other system processes, but you know it was, for example, a Python application. Well, we can search for that Python command using the following. If you look at the bottom, you can see that F3 is for search, so we're going to press F3. And now we're going to type something in. In my case, as a demonstration, I'll type in Python. And what happens is it has highlighted in white at the bottom here a Python application. Okay, so I'll delete that. Press enter. Now that is super useful, but not actually as useful as the next feature I'm going to show you. So the next feature I want to show is how we can filter the search list we've just done, but to result in only those search results appearing on the screen and nothing else. We do that using the filter feature. And filter, as can be seen at the bottom, is arrived at by pressing F4. So I'll press F4 now, and this time I'll type in Docker. You can see that by doing so, it allows us to find the processes we're after, matching our search term only, and will hide everything else. I generally use filter as opposed to search to simplify my screen when searching for processes. It's very, very useful and worth remembering. Just don't forget to remove the filter afterwards. I'm going to do that by pressing backspace and then pressing escape. There we go. Okay, lastly then, let's talk about terminating a process using htop. But to do that, I first need to set up a fake process for us to terminate. So let's exit htop, which we can do using Control-C, and set up that fake process. There we go. Now, a useful utility I demonstrated as part of my hosting a website video series, which incidentally you can find in my playlist for hosting a website, is called stress. Now, it will allow us to run a CPU at full capacity and create a fresh process for us. So let's install it first so that we can use it. So sudo apt-get install stress. Press enter. Now I already have it installed, but you may not, so make sure you do it. Once done, we can use it as follows to create a process. Stress space hyphen CPU space 1, which is to just use one CPU, and then I'm going to use the ampersand at the end. Now here I'm using the ampersand to create a background process so that it doesn't clog up our CLI interface. Don't worry too much about the ampersand, but I recommend you use it so that you can stress your machine a little without losing control of the CLI. Basically, this command without the ampersand would take over the CLI. So let's do that. Press enter to clear it. Okay. Now, with that done, we'll have a process running in the background. Let's head back now into htop to see what that looks like. As we can see, one CPU is running flat out because we're using the stress command to run a CPU at 100%. But because htop is ordered from the longest running process to the shortest running process, we're in a great position whereby we can see the process running right up here. Now I can use the up and down arrows in htop to change to a different process, but it's very conveniently selected it at the top because it's already the longest running process on my Raspberry Pi. Now for you, it might not be at the top. So let's use what we've learnt before to bring it to the forefront of our process tree. Press F4 to use the filter functionality and then type in stress. There we go. Okay, so back to the point of what we're doing here. To kill a process using htop directly, we can press F9. So I'll just press enter to lock in the filter. So by pressing enter, it locks it in. I'm now going to press F9, which is the kill command, and you can see that at the bottom. Now by pressing F9, it gives us loads of options for how to kill the process. What it'll actually do is send a signal to the process. A suitable one is sig term, which is signal terminate, and that's the default that it's hovering over already. So I'm just going to press enter on there, and it'll kill that process for us. There we go. Now our htop process list has disappeared, and that's because we still have a filter enabled. So I'll press F4, I'll delete the filter, and I'll press enter, and everything is back to where it was, but our CPU has gone down. Now our htop environment here has become a little corrupt by terminating the process, so I'll exit with Control C and go back in again to clear it out. Right, well that's it for htop. We know what the most important parts of it do. We know how to order the process list by column, how to search and filter by keyword, and we know how to kill a process. All key things. In my opinion, the top things you're going to need to do using htop. So moving on to clearing virtual memory then as the next part of this video. So if your virtual memory is non-zero, so if this bar swap is non-zero and your memory bar is not full, then you can flush your virtual memory back into your RAM to improve your performance. We do this as follows. It's something worth remembering. So I'll exit out of htop, type as I type, swap off -a, ampersand ampersand, swap on -a. I won't actually do it because I don't need to, but what it's doing, and you'll recognize the swap off and swap on commands excuse me, later on in this video series. But what they're basically doing is they're switching the swap off, which will clear it and automatically pull it back into RAM, and then it's switching swap back on again and presenting us with an empty swap space or swap file. As I say, I'm not going to do that, but that's how you do it. And it's worth having in your cheat sheet or memorizing or just knowing that it can be done, so that when you see that your swap memory is being used, don't ignore it. If it's above zero and your memory is nowhere near the top, then it's worth freeing it up. Okay. The last thing I want to do, and it's a little bonus really, is to show you how to increase your swap memory. By definition, increasing your swap memory will decrease your available storage because you'll be using some of your hard drive for swap space. As you could see on my Raspberry Pi, if I go back to htop, I only have 100 megabytes of swap space, which actually is a bit on the small side. So let's increase it to 300 megabytes. This will give me more flow over space should something use too much memory. So I'll go back out of htop. You can view your swap files by running the following command. Hopefully you'll recognize the concatenate command from the previous video. So cat, and then I'm going to use concatenate out a text file located in the proc directory, and it's called swaps. So this is just printing out the content of a text file. And what you can see is we've got a file here at this location. It's a swap file. It says it's a file here. It's approximately 100 megabytes in size, and 0 megabytes of it are being used at the moment. So what we're going to do is we're going to create an additional swap file, a second one, to increase the available swap memory on my system. What we do is we create a file with allocated memory, and then we simply assign it as a swap file object. So if you wish to do that, you can type along with me. Sudo, I'm going to use the command called fallocate -L, followed by the size of the swap file. Now, if I wanted to create a swap file in gigabytes, I could do something like this, 2G for 2 gigabytes, but I don't want to do that. I want to create a swap file which is 200 megabytes in size, so it's just 200 M. And the file I wish to create is just going to be at the root of the file system, and I'm going to call it swap file. So I'm going to press enter there. So that's created a file called swap file at the root of my operating system, and it's 200 megabytes in size. Now the next thing I'm going to do is I'm going to change the permissions on that file. Now we've not covered chmod yet in this video series, so for now just do this by rote, sudo chmod 600. 600 are the permissions for this file that we're going to set it as, and then / swap file. Press enter. Now we just need to make it into a swap file and switch it on. So do as I do, sudo mkswap / swap file. That makes it into a swap file object, and then sudo swap on. Now I mentioned you'd recognize this. This line is the same as what I demonstrated before when we were switching on and then switching off and then subsequently switching back on the swap functionality so that we could clear our swap back into main RAM. So it's the same command, we're just in this case not using it generally, we're using it instead on a particular swap file, which is the one we've just created. And that's it, nothing else to know. You allocate the space, you then change the permissions to 600, you make the swap file, and then you switch it on. Okay. That's it. Let's now check that this swap file exists. So let's use the concatenate utility again on the swaps file inside the proc directory. And there we go. So we can see we now have 2 swap files. This is the original one, and this is our new one. The new one is 200 megabytes in size. So combined, we should have a 300 megabyte swap file. Let's just go into htop by typing it at the command line, and let's check that it's been recognized by the kernel or by the shell. And there we go. If we look up here, we can see that I now have 300 megabytes of swap. So if you don't want to remember how to do this, just be aware that it can be done. And be aware that swap and virtual memory is nothing more than a file sitting on your hard drive being made available for overflow of your RAM into your swap space. Okay, excellent. Okay, that's it then for swap or virtual memory. Let's move on to the last part of this video, which is upgrading your system. So let's get out of htop because that's just a distraction. There we go. Okay, so when you upgrade your system, it might be a good idea to restart your machine as well. It's just a sensible thing to do every so often anyway. You don't have to, but I think it's sensible. So let's first cover how to restart your system before we look at what update and upgrade are all about. It's very simple to do. You simply have to type the following: sudo shutdown -r now. Now, I'll do that now, just to prove the point. There we go. So as you can see, I've just been kicked out of my SSH session with my Raspberry Pi. There are other ways of doing this, but I prefer this approach. The -r option is for restart, so don't forget to include it, otherwise the system will just shut down without restarting. And the now statement tells the shutdown utility to restart immediately. Okay, so for my Raspberry Pi 4, I typically have to wait about 30 seconds for it to come back up, which I'd imagine has about elapsed since I ran that command. So let's try and go back in using my SSH alias Pi4. Excellent. Interestingly then, if I use htop now, we'll see that my uptime has reset back to almost 0. Just for completeness, we can see it there. Okay. Right. Oh, and something else worth noting. My swap has reverted back to 100 megabytes. Now, this showing you how to increase a swap was a bonus in this video. There is a way of making this permanent, but if let's just go and have a quick look again at the swap file before we move on, and you can see it's disappeared. So in another video, maybe later, I'll talk about how to make it permanent, but it's just worth knowing that how I did it is temporary until you restart the system. But it's okay to do that because swap isn't something that you absolutely have to have consistent each time the computer is restarted. Okay. Right, back on to updating the system then. Firstly then, when we install something like a utility called stress, for example, we are installing a package. It's important we understand packages to understand what updating and upgrading are actually doing to our system. A package is a collection of items, for example, scripts, libraries, text files, a manifest, licenses, etc. And these items enable you to install a piece of software ordered in such a way that the package manager can unpack it and put it onto your system. Often packages are delivered via a distributions repository. It's worth noting that custom packages come from something called PPAs, and PPA stands for Personal Package Archive. Now, I'd like to make it clear that only custom repositories or custom packages come from PPAs. The main distribution doesn't, it comes from its own repository. It's a common misunderstanding and it's worth noting. Now, each Ubuntu version, for example, has its own set of repositories. Ubuntu actually has 4. It has main, universe, restricted and multiverse. I won't go through the details of what these are here, as it's a video in its own right to cover how this all works. And if you're interested and I get feedback, I might create one, but I won't do it here. Okay, but interestingly, for your information, if you're interested in seeing where your system is going to look for the repository, you can do so as follows. Cat for getting a printout of the text file. So again, you can see how useful it is. /etc/apt/sources.list. Okay, you don't have to do this. I've typed it quickly because you don't have to do it. It'll be the same on your computer, but I just want to demonstrate it here. I press enter, and the thing I want to show you here is this line. Because I'm running on a Raspberry Pi and because it's a Debian operating system or distribution, this is the directory where it's going to be looking for the distributions when it downloads them. Okay. Now in this case, because I'm using Raspbian, I only have main. I don't have universe, restricted, multiverse. They're really for Ubuntu. And it depends on your distribution as to what you'll have. But the important thing is, there's the URL, so you can see where it's going to look. Okay. Now, when you run update, you do so by typing in the following. You probably already know this. Sudo apt-get update. Okay? I won't do it, but that's what you do. What your system is actually doing when you press enter is it's using the apt tool to check the repositories at the URL I've just shown you, and then to store the information about the available packages and their versions in a cache on your machine. It doesn't actually update your packages at all. So that's really important to know. Sudo apt-get update updates nothing except references to packages. It just pulls the latest information pertaining to what is available in the repositories of your distribution, so that when you do use something like sudo apt-get install, the package you install will indeed be the latest available from your distribution. So, if that's what update is, what is upgrade all about then? Well, upgrade is the command which will actually go about installing new versions of your installed packages based on what's in your cache. So it should now be really clear why when you want to upgrade your system's packages, you have to update the cache first using the update command and then upgrade it. You may often see references in tutorials or on forums, etc. that say sudo apt-get update, sudo apt-get upgrade in that particular order, and this is why. Okay, well that's it for this video. It's covered 4 topics from my list, but let's just very quickly, before we wrap up, summarise what we've covered to help embed that knowledge, because I think it really does help to do a quick review. So very briefly, firstly, we have explored the essential tool htop, how to filter processes, search for processes, order them by one of the columns, and how to kill those processes. We also looked at what to look out for in htop and how it's structured. We have learnt about virtual memory, the fact it's just a file on your computer, how to flush it out, and indeed how to extend it and make it bigger. We've also looked at what systems update and upgrade actually do, and what a package actually is. If you found this useful, please do subscribe to my video series. It's the best way of showing appreciation for the work, and if you'd like to support my work and get any support from me, or if you'd just like to access the videos I produce early, please do visit my Patreon account. It would be very much appreciated. Okay, thanks very much, and I will see you in the next video.